There's something deeply satisfying about watching raw timber, massive, rough, and wild, get transformed into perfectly cut lumber that'll end up in homes, furniture, and structures around the world. And if you want to see that process done right, you don't need to look much further than the Scottish Highlands. Tucked away in the town of Nairn on the northeastern coast of Scotland sits one of the most respected family-run sawmills in the entire United Kingdom, Gordon & Son. Gordon & Son is a family business in every sense of the word. This isn't some faceless industrial operation run by a board of directors in a high-rise office. This is a sawmill where the people doing the work have skin in the game, where knowledge gets passed down from one generation to the next, and where the pride in every finished board is absolutely real. For decades, they've been supplying high-quality sawn timber to local builders, construction firms, agricultural businesses, and specialty woodworkers throughout Scotland and beyond. The logs arriving at Gordon & Son come primarily from sustainably managed forests in and around the Highlands. Scotland has invested heavily in certified forest management over the past few decades, and mills like Gordon & Son are part of that supply chain, working with timber that's been harvested responsibly, ensuring the forests that feed their operation will still be standing for the next generation. Now let's talk about what really makes this mill worth watching: the processing line itself. When a raw log arrives at the yard, it doesn't just get thrown onto a saw. There's a whole sequence of steps that takes place before a finished, graded piece of timber is ready to leave the premises. First, logs are sorted and staged in the yard by species, size, and grade. This initial sorting is critical. Not all logs are created equal, and feeding the wrong material into a production line without proper preparation leads to waste, machine wear, and inconsistent output. At Gordon & Son, the team knows their timber. They can look at a log and immediately begin assessing its value and best use. From the yard, logs are fed into the primary breakdown station, which at Gordon & Son centers on a powerful bandsaw head rig. This is the machine that does the heavy lifting, taking a full-size log and making the first critical cuts that determine how the timber will be broken down. Bandsaw head rigs are favored in quality-focused mills because they produce a thinner kerf, meaning less wood is lost as sawdust with each cut, compared to older circular saw setups. This matters enormously when you're working with premium timber. The head rig operator, and make no mistake, running this machine takes real skill, works closely with the log positioning system to optimize each cut. Logs are rotated and aligned so that the saw follows the natural grain of the wood as much as possible, maximizing the yield of clean, straight boards. Modern mills at this level use optimization software paired with scanning systems that assess the shape and internal structure of each log before the first cut is made. This technology can identify knots, grain deviation, and irregular shapes, then calculate the cut pattern that produces the highest possible value from that specific log. At Gordon & Son, this combination of human expertise and technology is exactly what sets their output apart. After the head rig breaks down the log into its primary cuts, known as cants, the material moves to the secondary breakdown stage. Here, the cants are processed through resaw machines, which slice them down into the specific board dimensions the mill is producing for a given order. This might be structural timber in standard construction dimensions, or it might be custom sizes for specialty orders. The flexibility to switch between these outputs is one of the reasons Gordon & Son has maintained its reputation as a versatile supplier. One of the most important and often overlooked parts of the sawmill operation is the edging and trimming stage. Raw sawn boards coming off the resaw don't yet have clean, parallel edges. They still carry the natural curve of the log on their sides, which is called the wane. Edger machines run the boards lengthwise through a series of parallel saw blades, squaring up the edges and producing a clean, consistent width. Then, trim saws cut the boards to their final length, removing any split or damaged end sections. What comes out of this stage is starting to look like the lumber you'd recognize: straight, square, and ready for grading. Grading is where Gordon & Son's reputation really gets built. Every board that passes through this mill gets visually inspected and assigned a grade based on its strength, appearance, and structural integrity. Knots, Grain patterns, moisture content, and dimensional accuracy all factor into this assessment. Scotland follows European timber grading standards, and mills supplying the construction sector must meet specific requirements around structural grade classifications. So this isn't a step you can rush or cut corners on. Gordon & Sons graders are experienced professionals who know their material deeply. After grading, the timber moves into the kiln drying phase. Fresh sawn wood contains a significant amount of moisture, sometimes well above 50% by weight. And this moisture must be removed before the timber is stable enough for most end uses. Gordon & Son operates kiln drying facilities that carefully control temperature and airflow to bring the wood down to the target moisture content, typically around 18 to 20% for construction timber, or even lower for furniture-grade material. Getting this step right is essential. Dry too fast and you risk surface checking and warping. Dry too slow and you lose efficiency and risk fungal development. The kilns at Gordon & Son are managed with the same attention to detail that runs through the entire operation. Once dried, timber goes through a final planing and finishing run if the order calls for it. Plain timber, smooth-surfaced on 2 or 4 sides, commands a premium in the market and is required for a wide range of applications. Gordon & Son operates modern planing equipment capable of producing consistent surface finishes across high volumes of material without sacrificing dimensional accuracy. The finished product coming out of this represents everything that a quality sawmill should deliver. Timber that's been selected carefully, processed intelligently, dried properly, and finished to a standard that builders and craftsmen can rely on. In a world where a lot of the lumber trade has moved toward cheap imports and commodity products, Gordon & Son represents a different philosophy, one that says the best timber is worth taking the time to do properly. And in the rolling, forested landscape of the Scottish Highlands, they've got the raw material and the know-how to back that up every single day. If you've spent any time around a busy sawmill, you know that speed and precision are everything. Get one without the other, and you've got problems. Either you're cranking out rough, inconsistent cuts at high volume, or you're producing perfect boards so slowly that the business doesn't make economic sense. What folks at Máquinas Águia have done with their twin saw system is figure out how to deliver both at the same time. And watching this setup work is genuinely impressive. The centerpiece of this operation is the SFG 1100, Águia's industrial-grade frame saw designed for high-throughput hardwood and softwood processing. This isn't a light-duty machine. The SFG 1100 is built to handle serious log volumes, and its twin saw configuration is where the real efficiency story begins. Traditional single-blade setups process one cut path at a time. The twin saw system runs 2 parallel blade assemblies simultaneously, meaning every pass through the machine produces multiple boards at once. This dramatically increases output without requiring additional passes or additional labor. You're essentially doubling your productive capacity on every single cut cycle. The machine's frame is engineered for rigidity under load. When you're pushing large diameter hardwood through a production saw, vibration and deflection are your enemies. They translate directly into surface roughness and dimensional inconsistency. Agia's engineers have addressed this with a robust cast and welded steel frame construction that minimizes flex, keeping the blades tracking true even under heavy cutting loads. The result is a surface finish quality that reduces downstream processing time and waste. What makes this particular sawmill setup especially effective is how the SFG1100 has been integrated with the multifunction block processor, a versatile processing unit that handles log-in feed, positioning, and initial breakdown before material is passed to the main saw. This block processor can orient and square incoming logs quickly, ensuring that the SFG1100 is always receiving material that's properly aligned and ready for precision cutting. The coordination between these two systems is what allows the line to maintain its pace without sacrificing accuracy. And then there's the material handling side of the equation, which is where a lot of sawmill operations lose time without even realizing it. Agia's installation includes a fully automated elevator and stacking system that handles finished boards the moment they exit the saw. Boards are automatically lifted, organized, and stacked into sorted piles, all without manual intervention. This matters for two big reasons. First, it eliminates the bottleneck that typically builds up at the exit end of a saw line when human stackers can't keep up with machine output. Second, it reduces worker fatigue and injury risk in one of the more physically demanding parts of the operation. The stacking system works continuously, matching the pace of the saws, so the entire line can run at full production speed without interruption. What you end up with is a system that thinks about the entire production flow, not just the cutting, but the feeding, the handling, and the stacking, as a single integrated unit. Every element is sized and timed to keep the others running without pause. That's the hallmark of good industrial engineering, and Agia has clearly done their homework. There's a certain kind of satisfaction that comes from watching a complete industrial system come together. Not just a single machine doing one job, but an entire production line, designed from the ground up, installed with precision, and running as a unified whole. That's exactly what Hack GmbH delivers, and the sawmill you're looking at in this clip is a perfect example of their engineering approach done right. Hack GmbH is a German company specializing in the planning, manufacturing, and installation of complete sawmill systems. Hack doesn't just sell equipment, they build entire processing lines, tailored to the specific requirements of each client's timber species, production volume, and output goals. The result is a turnkey sawmill that functions as a system, not a collection of individual machines that happen to end up in the same building. The production flow at this mill begins at the log intake and sorting station. Raw logs arrive from the forest either by truck or via an integrated log yard conveyor, and they move into an automated sorting line where they're measured, diameter, length, and curvature by a 3D scanning system. This scanner doesn't just measure the outside of the log, it builds a complete digital model of the log's geometry, which feeds into the optimization software running the downstream cutting decisions. This is where a modern, well-designed mill separates itself from an older, manually operated operation. From the sorting line, logs are fed into the primary log breakdown station, which at this Hack GmbH installation centers on a horizontal bandsaw head rig. Hack GmbH engineers have a strong preference for horizontal bandsaw technology in their head rig installations, and the reason is straightforward. These machines combine a thin kerf, minimizing sawdust loss on every cut, with the structural rigidity needed to maintain blade tracking accuracy on large diameter logs at production speeds. The head rig at this mill is fitted with an automatic blade tensioning and guide system that continuously adjusts to maintain optimal cutting geometry, even as the blade heats up during heavy use. This detail might sound minor, but it directly impacts surface finish quality and dimensional accuracy on every single board that comes off the machine. The log carriage feeding the head rig is a fully programmable, servo-driven positioning system. Once the optimization software has determined the ideal cut pattern for a log, that pattern is loaded into the carriage control system, which then automatically positions and rotates the log for each successive cut without requiring manual adjustment between passes. After the head rig makes the primary breakdown cuts, producing cants from the larger logs, material moves on twin roller conveyors to the secondary processing line. Here, a multi-blade circular resaw takes each cant and slices it down to finished board dimensions in a single pass. The multi-blade configuration is a key feature of the Hack GmbH system design. Rather than making multiple individual passes to reach final thickness, the resaw's gang of parallel blades cuts the entire cant into its component boards simultaneously. This is where the line's throughput really shows. A cant that would require 3 or 4 passes on a single blade machine is fully broken down in one controlled pass through the multi-blade resaw, maintaining consistent dimensions across all boards cut from that cant in the same moment. Alongside the resaw, the line features an edger that processes boards requiring edge squaring, removing the wane left by the natural curve of the log and producing clean, parallel edges ready for grading. The edger at this mill uses an optimizing infeed system that reads the incoming board geometry and automatically sets the blade positions for maximum board width recovery. On boards with irregular wane, this optimization step can recover additional usable width that would otherwise be lost to oversized edge trimming, a detail that adds up to significant material savings over a production shift. Trim saws at the end of the primary line cut boards to their final lengths, removing damaged ends and producing clean square cuts. Trim saw positioning is also controlled by the optimization system, which tracks each board through the line and applies the trim schedule that maximizes usable length for the grade of material being processed. Following primary processing, all timber at this Hack GmbH installation moves into the sorting and grading section. This is a critical step that the Hack GmbH system handles with a combination of automated optical scanning and manual grader inspection. The optical scanner reads surface features, knot size and position, grain deviation, surface checks, blue stain, and assigns a preliminary grade classification. Human graders review borderline pieces and apply final judgment where the scanner's confidence threshold isn't sufficient. The combination of automated speed and human expertise produces consistent, reliable grading outcomes at volumes that a purely manual grading line couldn't sustain. From grading, timber is directed by an automated sorting line into separate outfeed packages by grade, species, and dimension. These sorted packages feed directly into the kiln loading system, where stacked timber is built up on kiln trolleys ready for drying. Hack GmbH has integrated the sorting and kiln loading functions so that material flow from grading to kiln entry is fully automated. No manual movement of timber between these stages. No bottlenecks. No mixing of grades or species waiting on a loading dock. The kilns themselves are high-capacity forced air chamber kilns, sized to match the output capacity of the primary line so that green timber never backs up waiting for kiln space. Temperature, humidity, and airflow schedules in the kilns are managed by a process control system that adjusts drying conditions in real time based on the species and starting moisture content of each charge. After drying, timber exits the kilns with target moisture contents appropriate for its intended use, whether that's 18% for standard construction material or tighter tolerances for specialty products. The finished timber coming off this Hack GmbH line reflects everything that separates a properly engineered sawmill from a makeshift operation. Consistent dimensions, accurate grading, controlled moisture content, and a material flow that runs continuously without the bottlenecks and handling losses that plague poorly designed systems. This is German industrial engineering applied to the timber industry. Rigorous, efficient, and built to run reliably for decades.